Good morning. Is my screen visible to all of you?
Yes, ma'am.
Good morning. Yes, ma'am.
So,
Yes, ma'am.
yes. Okay. So today we will discuss the first law application. So first law application to the closed system and your open system. Today I'm going to discuss the first law applicable to the closed system, which is undergoing the change of cycle as well as the change of state. So first one is the first law of thermodynamics, which is applicable for the closed system. First law for closed system. I can write here change of cycle. Or simply you can write undergoing a cycle. Or you can give that heading. So in this case, we will discuss the energy transformation. Okay. To discuss this one, we have to draw the closed system. Here I have taken the energy is transferring in one form, that is paddle wheel work, that we have already discussed. There we are having the work transfer. That one only I'm going to draw here. Okay. So this is your paddle wheel arrangement. Here we are having the wheel, and this is your wet, and this one is a pulley arrangement. So in this case, suppose initially this vessel, this one is the container vessel, it is insulated or adiabatic type. So there is no heat transfer from the surrounding and from the system to surrounding. Okay, so suppose we are putting one thermometer here. So initially what we will do, we will put some wet here. So due to the turning action of the paddle wheel, inside here the fluid water we have considered in this case. So what will happen due to the fall of the weight, it will drive this paddle wheel through the pulley. So initially, suppose your temperature is T1, initial temperature is your T1. Okay, so which is same, which is this temperature is equal to your atmospheric temperature, we can say. So due to this paddle wheel action, there will be the work transfer. So due to this work transfer, let us consider that there will be the little rise in temperature, and that temperature we can consider as T2. So in this case, pressure is constant, so which is atmospheric pressure. So in this case, if you will draw the PV plot, there will be the initially work transfer. So that is your P12, sorry, W12, because work transfer is here in this case. So in this case, suppose we are drawing the diagram, we will get work transfer. So in this case, there is the increase in the temperature. So here I can give the state 1, and this one is the state 2. So there is your work transfer that I can write W1, 2. Okay. So after that, suppose this system, we have removed that insulation. Okay. So what will happen? There will be the heat transfer. So later on, suppose we are removing
That
the
is thermometer.
insulation. Yes, this thermometer is used to measure the temperature. Okay. So here we have given the insulation, right? Initially, we have considered it is the adiabatic vessel, and that time we are doing the paddle wheel work. So there is the work transfer, that is the W12, due to which there will be the little rise in temperature. That rise in temperature is considered your T2. Okay. So in that case, what will happen? We have considered the system from 1 to 2. There is the energy transfer. So now what we will do? We will remove the insulation. Let that thermometer will be there. Okay. So if you are removing this insulation now, there will be the temperature difference. Due to that one, there will be the heat transfer.
मैम
So
ये ग्राफ कैसे प्लॉट हुआ? कैन यू एक्सप्लेन दिस?
okay. एक्चुअली ये कोऑर्डिनेटेड को आप एक्स वाई भी ले सकते हो, ठीक है. इंस्टेड ऑफ टेकिंग पीवी, यू कैन राइट एज एक्स वाई. Okay, it will be better understood. So if I am writing the PV, in that case you will have a little confusion in this case. So because there I'm showing you the if I'm plotting this graph from 1 to 2, then it will little bit it will be the compression work. Okay. So better explain in terms of the x and y coordinate. Okay. So now suppose there is the work transfer, then I can write like this. There will be increase in the temperature from 1 to 2. Okay. So that is your W1, 2. So suppose I am removing this insulation, then the temperature will again come back to its original temperature, that is your T1. But there is the heat transfer. So heat transfer means then your system will come from state 1 to state 2. So in this case, your temperature will be equal to T2 will be equal to T1. Okay. So here
मैम
in
व्हाट
this
इज
case,
एक्स एंड वाई हियर?
nothing I have considered only coordinate. Okay. Just to show the change of state, I have taken the XY coordinate, nothing else. Okay. So in this case,
X will be temperature only.
Yes, you can take a temperature only. Okay. So here, no, it will not temperature. Okay. Just to explain this one, I have taken that there will be the increase in the temperature. Okay, in XY coordinate. So in this case, there will be the heat transfer, that is your Q to 1. Okay, after removing the insulation. So in this case, we can say that the amount of heat transfer, that is your Q to 1 from the system during the process is your Q to 1. Okay, so here, if you are observing, this system will execute a cycle. This system will execute a cycle. How? Initially, it is going from state 1 to state 2. Again, it is coming back from state 2 to state 1 by transferring the heat in this process. So, in this case, we can say that the initial and final position of the state of the system is same. Okay. So, in this case, your temperature will again T1, whatever it was in the initial condition. Okay. So during
Ma'am,
the uh, uh,
how can the temperature change from T2 to T1 in it?
due to the paddle wheel work or steering work, we are considering that little increase in the temperature of this system. So system we have taken here is the water or in gas or in liquid we have considered. Okay. So
नो
due
मैम,
to the
माय क्वेश्चन
paddle,
इज कि जब टेम्परेचर बढ़ रहा है तो फिर वो लोअर कैसे में चला जा रहा है? मतलब इनिशियली कैसे,
see,
इनिशियल स्टेट में कैसे चला जा रहा है?
इनिशियल स्टेट में आप इनिशियली ज्वाइन किए थे क्लास या अभी
यस
ज्वाइन
मैम।
कर रहे हैं? अभी ज्वाइन कर रहे हैं या पहले से ज्वाइन किए थे? अब देखिए, पहले जो मैं ड्राइंग की थी वो आपका एडियाबेटिक वेसल था, याद
ओके
आया?
मैम।
सो जब एडियाबेटिक हम कंसिडर कर रहे हैं और पैडल व्हील वर्क हम दे रहे हैं, तो ड्यू टू दिस पैडल व्हील वर्क, दैट वर्क इज वी आर कंसिडरिंग W12. So इसके वजह से due to the work transfer there will some temperature rise. We are considering that one is your T2.
ओके मैम।
Okay. Due to this work transfer, we are considering that this adiabatic vessel inside which we are having the system, that system temperature will rise a little bit. That is your temperature is T2, whereas your pressure is always 1 atmospheric pressure. The pressure is your constant. So in this case, your process 1 to 2 undergoes a uh, undergoes a change of state. So when both energy transfer is there in this case, we can see that here it is the complete cycle. So it is the complete cycle. So we can say that system will execute a cycle which consists of a definite amount of your work transfer or work input to the system, and there is also the heat transfer of a definite amount. So this heat transfer is from the system. Okay. So here we can say that this work transfer is always proportional to your heat transfer. Okay, in this case. So this is considered for the cycle, or else I can write here the in case of your cycle, summation of energy input is equal to the summation of energy output. So this proportionality constant we can write as the J, which is known as the Joule equivalent. Okay, or it is also known as the mechanical equivalent of your heat. So we can write like this. So in a complete cycle, there is the all energy input will be equal to the energy output. Okay. So this work and heat transfer in the cycle can be right by putting the proportionality constant, that is the Joule equivalent. These two are equal um, in case of the cycle. Okay, so it is your algebraic expression. So this one also we can write that cyclic integral of your dw is equal to your um, cyclic integral of your dq. Okay. So the this is the first law for a closed system, which is undergoing the change of the cycle. So in case of the change of the cycle, we can say that the whatever the energy transfer is there, um, when input is there, that is equal to the output. Okay, so this is for the cycle. So now we will discuss the closed system, which is undergoing the change of state. So already we have discussed that this is applicable for the system which is undergoing the change of cycles. So in this case, it is your algebraic summation of all energy transfer across the system boundaries are zero. If it is coming this side, then this will be equal to zero. So we can say that in this case, your energy is conserved. So in case of the first law for the change of state, so in this case, suppose there is both work and heat transfer are involved in the system. Suppose Q amount of is enter into the system, and due to this heat transfer, there is the work transfer. That is your work. That is your W amount. Okay. So in this case, we can say that the system is undergoing the change of state. So suppose it is the state one and this is the state two. So if there is the heat transfer in the system, then it will give the work output due to the change of the state. Okay. So suppose there is the change of state during which both. Okay. So suppose there is a change of state uh, of the system during which both heat and work transfer are involved, then there will be the accumulation of energy within the system. So here I have shown Q is the amount of heat transfer to the system and W is the amount of work transfer from the system. So here in this case net energy transfer will be how much, that is the Q minus W. So this will be stored within the system or accumulated within the system. So that energy storage is neither heat or neither your work. So this we can say that this is the internal energy or simply your energy of the system. So that we can write as Q minus sorry, this will be the delta E, delta E. Okay, so Q minus W will be the delta E. So when there is the change of state, and if you are applying the first law, so all of you know that first law means it is the conservation principle. So where we are considering that energy never be destroyed or created, it will always conserved within the system. Okay. So, if you are considering only the change of state, so in that case, your energy transformation or net energy transfer will be Q minus W is equal to your delta E. Okay, so delta E is nothing but it is the increase in the internal energy or increase in the energy of the system. So sorry, this equation again we can write as Q is equal to the delta E plus W. So जब हम change of state की consider कर रहे हैं, so in that case we will use this equation for solving of our problem. Okay, so suppose there is the many energy transfer in the system. So if I am writing here, it is your system. So suppose there we are having the Q1 amount of heat transfer, and here it is your Q2, and again here it is your Q3, right? So suppose there is the um, W1 amount of water transfer is there, and W2 amount of work output is here, and W3 amount of work output from the system is there. So there are many energy transfer quantities involved in this process. So here we have to find out what is the total energy transfer. So we will use this equation. So in this case, we will use the sign convention. So heat input means we are considering it is the positive quantity. So here you have to write Q2. Okay. So again we are having the Q through Q3, that is the heat input. So here you will write positive quantity, that is your Q3. Okay. So Q1 is your heat transfer from the system. So here your sign convention will be negative. So this will be minus Q1. So there is it is your heat transfer to total heat transfer. Then we will have the total work transfer. So delta E we can write it as simply it is the energy stored increase in the internal energy. Then in place of the W we can write the total work transfer. So here also we will include the sign convention. So all of you know that when there is the work input, so it will have the negative sign, right? So suppose in this case work output. So here we will consider the uh, positive sign. So it is the positive means here I can write W2 plus W3 minus W1. So this is the equation applicable for the change of state, or here applicable for the process. Okay. So this equation is only used when there is uh, a closed system and it is undergoing the change of state. So this equation can be applicable. So this is your first application in case of the cycle, in case of your state. Okay. So here we are getting the new term, that is the internal energy. So again there is the sometimes we are proving that your internal energy will be the property of the system. So we have to prove that one. Okay. So suppose we are having the PV diagram. So there is the change of state of the system from state 1 to state 2 by following the path A. Okay. So again it is returning back to the state 2 to state 1 by following the path B. So in this case, the system is undergoing the change of cycle. Okay. So change of cycle means we can write in this case your W cycle. Okay. So suppose we are considering the individual process 1 to 2 by following the path A. For the path A, we are applying the first law. So in this case, the equation will be QA, that is your delta EA, plus WA. So similarly for path B,
Ma'am, will there be a J factor?
no,
Ma'am, but previously it was told uh, W cycle equals to J
it,
into Q cycle.
it is your constant. Okay. So constant will have, if you will have any value, you can put it. So or else you simply remove this J. Okay, it is for the constant of proportionality. We have written it here. So during the solving of the problem, no need to include this J, because J value will be not provided in your question, in your problem. Okay. Got my point? So juice equivalent we are not providing.
So ma'am, answer will not vary. It will be directly W cycle equals to Q cycle.
It will vary if we are considering the practical example. So there it will no, it will not vary. It is the constant. Okay, juice constant.
Unlike if Q cycle is a particular value, and if there will be, if Joule's constant is 1, like we have taken, then W will be equals to Q. But if J has a different value, then W will have a different answer.
Yes, but J will be we are taking as the constant. Okay,
As unity.
as unity.
Okay, ma'am.
Okay. So first law applied for the path. So it is for the process. Okay. So QA is equal to delta EA plus WA. So similarly for the path B, we can write as QB is equal to your delta EB plus WB. Okay. So in this case, the equation I can give it is the 2 and it is 1 and it is the P. Then this energy transfer within in the cycle, we can write this two equation 2 to 3 in the form in the equation 1. Then we will get this equation 1 will be your WA plus WB is equal to your QA plus QB. Okay, so if you are bringing this equation, this will be the QA minus WA is equal to your WB minus QB. So this equation will yield into the delta EA is equal to minus delta EB. So this is the equation where we are carrying the process from 1 to 2 and 2 to 1 by following the path A and B. There we are getting this equation. Similarly, suppose we are following another path, that is path C, and you are bringing the system from 2 to 1. So here the cycle will execute between path A and path D. So it will give you the complete cycle. So in this case, similarly for the path and uh, similarly for path A and C, we are having the same, we will have the same equation, that is delta EA minus delta EC. Delta EA is equal to minus delta EC. Okay, so if you are observing both the equation, this one and this equation. So here in this case, the left hand side is the change in internal energy in the path A, and both will be same in case of the path A and B and path A and C. So these two equation will be equal to your delta EB is equal to delta EC. So we can conclude that energy transfer in this case in these two states of the system is the same. In two state mean that is in state 2 to 1 it is returning by following the path B is equal to the change of state from 2 to 1 by following path C. In this case, the energy transfer will be, or net energy change will be same. Okay, so whatever may be the path of the system, it is following. So in this case, your net energy change will be same. Okay, so if there is the net energy change is same, then we can say that this energy change is nothing but it is the point function or it is the property of the system, because it is dependent on the end state of the system. It does not depend upon the path C or path B. Okay. Now you got my point. So from this equation, we can say that the energy, net energy change uh, or accumulation is nothing but it is the point function and it is the property of the system. So now we have proved it. It is the point function and property of the system. Okay.
Ma'am, once
So
can you
now,
go previous ma'am?
okay, please tell me.
Ma'am, can you switch to third slide?
This here.
Yes, ma'am. Okay, ma'am.
हम्म। यहाँ पे हम क्या करें, जो नेट एनर्जी चेंज है ना, डेल्टा ई, उसको हम प्रूफ कर रहे हैं, ये प्रॉपर्टी ऑफ द सिस्टम। इट इज नॉट अ पाथ फंक्शन, इट इज द पॉइंट फंक्शन। जैसे हम वर्क और हीट को प्रूफ किए थे कि ये है आपका पाथ फंक्शन, इट इज नॉट द पॉइंट फंक्शन। तो यहाँ पे वही कर रहे हैं हम, जो डेल्टा ई जो एनर्जी चेंज हुआ, नेट एनर्जी चेंज हुआ, उसको प्रूफ करना चाह रहे हैं। तो यहाँ पे हम क्या कर रहे हैं, आप सिस्टम को ले रहे हैं, चेंज कर रहे हैं स्टेट वन से स्टेट टू, ठीक है, बाय फॉलोइंग द पाथ ए, again it is returning back to state 1, then by following the path b, then it is undergoing the change of cycle, it is execute a cycle. So again we are bringing back the system from 2 to 1 by following the path c. ओके, तो यहाँ पे हम लोग बोल रहे हैं जो भी पाथ वो फॉलो कर रहा है, उसके ऊपर हम नेट एनर्जी चेंज डिपेंड नहीं कर रही है, बट वो डिपेंड कर रही है आपके एंड स्टेट के ऊपर, पाथ के ऊपर डिपेंड नहीं कर रही है, ठीक है। व्हाट माय पॉइंट। तो ये इक्वेशन आप दो इक्वेशन यूज करेंगे, यहाँ पे आपका साइकिल का इक्वेशन ये यूज हुआ, और दूसरा होगा ये स्टेट चेंज में, यहाँ पे आपका वर्क ट्रांसफर, हीट ट्रांसफर हो रही है, नेट एनर्जी ट्रांसफर इज योर डेल्टा ई ए। सिमिलरली बी में भी वही इक्वेशन लिखेंगे, सिमिलरली सी में भी वही इक्वेशन लिखेंगे। यहाँ पे सी में हमने लिखा नहीं है, आप लिख सकते हैं क्यू सी इज इक्वल टू डेल्टा ई सी प्लस डब्ल्यू सी। ओके, यू कैन नेम इट एज इक्वेशन। तो ये जो साइकिल के लिए हमने ये फॉर्मूला यूज किया, तो समेशन ऑफ साइकिल डब्ल्यू इन द साइकिल विल बी इक्वल टू डब्ल्यू ए प्लस डब्ल्यू पी। Similarly, ये साइड राइट हैंड साइड समेशन ऑफ Q in the cycle will be QA plus QB। ओके, तो अब इसको क्या करेंगे, QA माइनस WA, इसको रीअरेंज करेंगे, WB माइनस WQ राइट हैंड साइड आ जाएगा। तो ऑल ऑफ यू नो दैट QA minus WA will be equal to your delta EA। So net energy transfer will be equal to the net energy change within the system, or energy stored or accumulation within the system। ओके, सो राइट हैंड साइड में भी वही हुआ है, तो यहाँ पे माइनस डेल्टा ये भी होगा, क्योंकि यहाँ पे क्यू भी माइनस डब्ल्यू भी होगा, ठीक। तो ये हमने एक साइकिल के लिए कंसिडर किया है, वो जो है कि ए बी के लिए है, तो हमने ये इक्वेशन लिखा। सिमिलरली यू कैन राइट इक्वेशन फॉर दिस ए एंड सी। तो यहाँ पे एन सी एफ साइकिल एग्जीक्यूट होगा, तो उसके लिए आपका इक्वेशन हो जाएगा ये। अगर बोथ एक इक्वेशन को आप कंसिडर कर रहे हैं, लेफ्ट हैंड साइड तो सेम ही है, राइट हैंड साइड आपका चेंज ऑफ इंटरनल एनर्जी हो रही है। यहाँ पे देखिए डेल्टा ई ए माइनस is equal to minus delta EB. So in this case, delta EA is equal to minus delta AC. So if we are comparing these two equations, then we can write as delta EB is equal to delta EC. Then from this equation, we can say that the change in energy between the two states of the system is same। Okay, so ये आप जो भी पाथ फॉलो कर रहे हैं, चाहे बी हो या चाहे सी हो, उसके पाथ के ऊपर डिपेंडेंट नहीं है, ये आपका एंड स्टेट के ऊपर डिपेंडेंट है। तो वही यही है, तो एंड स्टेट के ऊपर डिपेंडेंट है, देन दैट इज द पॉइंट फंक्शन एंड प्रॉपर्टी ऑफ द सिस्टम। नाउ इट इज गुड। ओके, so I have written in one class so that cyclic integral of any property is the 0. So in this case, we can write cyclic integral of dE is equal to your 0, or cyclic integral of your dV is equal to your 0. Okay. If it is the point function, energy is the point function. In that case, cyclic integral of dE is equal to 0, because the initial and final state are same. So that's why it is 0. So in case of this first law application, there we are having one fictitious machine, which is known as your perpetual motion machine of your first kind, that is your PMM1, perpetual motion machine of the first kind. Sorry. So this is known as your PMM1. So it is the one machine which is fictitious type, or we can say it is impossible. So that means, suppose it is your engine which is giving you the work output without any energy transfer, without any heat input. Suppose we are considering any machine which will give you the continuous supply of your mechanical work without other form of energy which is entering to the system or leaving from the system. So this type of machine is not possible. So there will be always appearance of energy transfer to the system, then only it will give you the mechanical work output. So this is known as your perpetual motion machine of first kind. So converse is also true. Converse is also true means, so suppose it is your engine. So suppose it is giving you the continuous mechanical work input, or continuously consuming the work without any appearance of your energy in any other form. Okay, so there is not possible this type of engine where we are giving the continuous work or continuous consumer of work without some other form of energy appearing. Okay,
Ma'am,
so this
that is
type.
some sort of representation, like in Q you are doing dotted line.
जी
हम ये कोई रिप्रेजेंटेशन है क्या जो क्यू में आप एरो को डॉटेड से रिप्रेजेंट कर रहे हैं?
हाँ, डॉटेड में इसलिए रिप्रेजेंट कर रहे हैं ये जो हम बोल सकते हैं कि इस टाइप ऑफ एनर्जी ट्रांसफर नहीं हो रही है. ठीक है, डॉटेड मीन्स वो है ही नहीं, दैट आई एम गोइंग टू से. ठीक है, डॉटेड लाइन जो यहाँ पे कर रही हूँ, ये इसलिए कर रही हूँ कि यहाँ पे कुछ है ही नहीं, हम जस्ट इमेजिनरी टाइप का कर रहे हैं. ठीक है, यहाँ पे जैसे देखिए कि यहाँ पे आपका कंटिन्यूअसली कंज्यूम हो रही है वर्क, अगर यहाँ पे कुछ भी नहीं है, कुछ भी आउटपुट दे ही नहीं रही है. ठीक है, समझ पा रहे हैं. तो दिस टाइप ऑफ एनर्जी, दिस टाइप ऑफ इंजन इज फिक्शियस इंजन. So this type of engine we can say PMM1 type of engine. Okay. तो डॉटेड लाइन इसलिए मैंने लिखा कि जैसे कि आपका हो रहा है जो फर्स्ट लॉ में हम लोग कंसिडर कर रहे हैं, अगर एनर्जी ट्रांसफर हो रहा है तो आपका यहाँ पे आउटपुट कुछ हो रही है ना. तो चाहे वो हीट फॉर्म में क्यों ना हो, चाहे वो वर्क फॉर्म में क्यों ना हो। अगर आप इसको हीट इनपुट भी दे सकते हैं तो यहाँ पे वर्क आउटपुट होनी चाहिए। ठीक है, समझ पा रहे हैं? तो उसी को मैंने डॉटेड लाइन किया था कि यहाँ पे आपका एनर्जी ट्रांसफर होनी चाहिए पर यहाँ पे हो नहीं रही है। ओके, तो आप सिंपली इस टाइप का भी लिख सकते हैं। ठीक है, so this is your PMM1 type of engine. So energy for the isolated system is your zero, DE zero हो जाएगा. So in that case, E is your constant. So energy of an isolated system will always a constant. ठीक है. So this is for the first law applicable for the closed system which is undergoing the change of cycle, and then we have discussed the undergoing the change of state. Then we have discussed that there is the energy is the property of the system. It is the point function. Then we have discussed the PMM1 type of machine. Okay, so which is the impossible engine or fictitious engine, जहाँ पे आपका continuously work दे रहा है without consumption of any other form of your energy. Okay, so in this case there is a continuous consume of your work or energy uh, without any appearance of other forms of energy. Okay, so that is your PMM1 type of engine. So that's all for today. So Ritika, please send me attendance of today's class.
Okay, ma'am.
So today evening I will send some questions. So I have prepared some question. I will give you. And, we'll solve it and try to submit within this week. Okay. Thank you.
Ma'am,
Oh, well,
uh, ma'am, if a paddle wheel is working and its rotor is in a compartment which is filled with vacuum, there is no fluid inside, then
yeah.
can we say it is PMM of first kind? It is taking work input but not giving any heat output.
No, PMM1 is only related to the engine. Only related to the engine. जैसे कि आप आइस इंजन ही कंसिडर कर लीजिए, ये वैक्यूम सिस्टम या इसको नहीं बोल रहा है। ना यू गॉट माय पॉइंट। आप जो वो एग्जांपल दे रहे हो कि वैक्यूम सिस्टम को कंसिडर कर रहे हो, तो उसका वो नहीं बोला जा रहा। ये है आपका एक इमेजिनरी मशीन जहाँ पे ये इम्पॉसिबल होता है कि आप कंटिन्यूसली वर्क आउटपुट दो विदाउट एनी हीट इनपुट। जैसे ही आपका बाइक हुआ, आप कैसे चलाओगे बाइक को? आप सोचोगे कि मेरा बाइक चले, पर उसके लिए आपको तो पेट्रोल जो उसका प्रोसेस होती है रेसिप्रोकेटिंग इंजन में, वहाँ पे एयर फ्यूल मिक्सचर बर्न होगी तब जाके वो वर्क आउटपुट देगा ना। यहाँ पे वही बोला जा रहा है कि आपका कोई भी ऐसा मशीन नहीं है जहाँ पे आपका वर्क आउटपुट देगा पर वहाँ पे आपका हीट इनपुट नहीं होगा। जहाँ पे हीट इनपुट होगा वहाँ पे वर्क आउटपुट पॉसिबल है। अगर हीट इनपुट नहीं है तो वर्क आउटपुट नहीं है। नॉट ओनली हीट इनपुट, अगर वहाँ इलेक्ट्रिकल वर्क दे रहे हो तो आपका सॉफ्ट वर्क वो देगा। अगर इलेक्ट्रिकल वर्क नहीं दोगे, सॉफ्ट वर्क कैसे देगा? मोटर रन नहीं करेगा तो आपका सॉफ्ट कैसे रोटेट होगा? उसका कहने का मतलब ये है कि कोई भी इंजन हो, वहां पे एक एनर्जी जो ट्रांसफर के लिए और एक एनर्जी हमें चाहिए होती है, इनपुट चाहिए होती है। समझ गए?
Okay, ma'am.
आई गॉट माई पॉइंट। हाँ, लास्ट क्लास आप लोगों का एक डाउट था जो मैं बताई थी, फ्री एक्सपेंशन प्रोसेस है ना। सो फ्री एक्सपेंशन प्रोसेस में आप लोगों का लास्ट क्लास हम प्री एक्सपेंशन प्रोसेस कंसिडर किए थे. सो प्री एक्सपेंशन प्रोसेस में हमने 2 कंपार्टमेंट लिया था. वन साइड आपका गैस था, अनदर साइड वैक्यूम था. तो यहाँ पे हम लोग अगर ये पार्टीशन वर्क को रिमूव करने में जो वर्क इन्वॉल्व होती है उसको अगर हम कंसिडर नहीं कर रहे हैं, सो देन देयर द नो वर्क ट्रांसफर विद इन द सिस्टम. तो ये जो फ्री एक्सपेंशन प्रोसेस में वर्क ट्रांसफर हो रही है, ये irreversible वर्क प्रोसेस हो रही है. So this process will be the irreversible process. So यहाँ पे आपका quasi static process का इक्वेशन यूज नहीं होगा. जो सिंपली जो इंटीग्रेशन ऑफ पीडीबी ये फॉर्मूला यूज नहीं होगा. ओके, सो यहाँ पे irreversible प्रोसेस में आपका वर्क ट्रांसफर के लिए और एक इक्वेशन यूज होगी. यहाँ पे हम सेकेंड लॉ ऑफ थर्मोडायनामिक्स जब हम डिस्कस करेंगे वहां आप लोग को मैं समझा दूंगी. ठीक है, तो यहाँ पे आपका जो है रेजिस्टेंस के हिसाब से जो फ्लो हो रही है, इसीलिए आपको हम इसको यहाँ पे क्वासी प्रोसेस कंसिडर नहीं कर रहे हैं. दैट मीन्स रिवर्सिबल प्रोसेस कंसिडर नहीं कर रहे हैं. व्हाट माय पॉइंट? जो लास्ट क्लास में बहुत जन ने ये डिस्कस किया था, मैम देयर इज नो रेजिस्टेंस एट द सिस्टम बाउंड्री, है ना? है ना? याद आया है कौन क्वेश्चन पूछा था जो रेजिस्टेंस नहीं हो रही है? So this is not the quasi-equilibrium process. So that's why the work cannot be calculated from this PdB relation. Okay, so because there is no resistance at your boundary as your volume increases, so we can conclude that the system is no work done in this process. No work done in this process of filling the vacuum. Got my point? So it is your free expansion process. So इसके लिए free expansion process में ये PdB वर्क formula use नहीं होगी. Okay. So thank you all. I have another class, MTech class. Okay, so which I have scheduled at 12:15. Okay, thank you all. Please give me your roll number. Ritika, please send to my WhatsApp.
Okay, ma'am.
Thank
I'll
you,
send
thank
it.
you, thank you, thank you,
Thank you, ma'am.
Thank you, ma'am.
thank you,
Thank
thank
you.
you.
Thank you very much, ma'am.
Thank you, ma'am.
Yes, yes, yes. Tell me.